Alrighty, I'm going to go through how to do the wave superposition worksheet. All right, so the way that this works is you have two wave pulses, A and a B. A is in red and on the left, and B is in blue and on the right. And each of these waves are going to move with a speed of 1 square per second. So at the beginning here, this is at 0 seconds. So my time is at 0 seconds. And so that's where it is at the very beginning. And then 1 second later, A is going to be one box farther to the right. So if I have my wave here, 1 second later, it's going to be moved right to there. And then I just need to figure out where that is. So I need to put it right there. All right. Now, it's kind of hard to do this on your own, but like with just a pencil. So you can also do like a dotted line. So 1 second later, it's one box farther to the right. And so then instead of it being there, it's one farther. So now A is right there. And then you're going to go ahead and continue this along. It was there. So now it's going to be one farther, which will put it right here. And the last one, I'll put it right about there. All right, so now we've had our wave A move to the right, and wave B, or wave pulse B, is going to move to the left. So B originally was here. 1 second later, it'll move one more box to the right. So now my wave is going to be there. And this one was here. And now it's going to move one more to the left. Now, you don't need to do these dotted lines. If it's helpful for you, that's great. Otherwise, don't worry about it. Oh, this one is where it's going to line up perfectly. So at 3 seconds, both of these waves are going to be in the same place at the same time. And then the wave pulses will pass through each other. And at 5 seconds, they will essentially be opposite of each other there. All right, so that's what it looks like at 5 seconds. We have the red and the blue done. And so now what we need to do is add the green. Now, the green one, the whole point of that is to look at what the wave will look like if you send these two wave pulses through a string towards each other. We also have long, they're kind of like springs. Those show this as well. And I will attach some links to those videos. Or you could use a really giant slinky to also take a look at this phenomenon. So think of these as two people are going to wiggle a string or a long spring, and the wave pulses will travel down towards the center, overlap with each other, either constructively or destructively, pass through each other, and then come out the other side. So that's exactly what we're seeing happen here. Now, the way to add them up, I'm actually going to start with the 2 second one. Because I think that this does the nicest job of actually looking at what is going on. And so what you're going to do is you're going to see, okay, how tall is the red wave? So the red wave here, this is your 0, by the way, this arrow here, that represents your origin or your 0. So here the red wave is at 0, and then all of a sudden it jumps up to a height of 2, and then it goes back down to 0 again. While the blue wave is at 0 and then jumps up to 2 and then goes back to 0 again. So the green wave, all you need to do is add the two waves together. So you're doing the red plus the blue to equal your green. Alrighty, so for this first part, we have red and blue are both at 0, and 0 plus 0 is 0. So my green line is going to stay here while both of them are 0. At this point, then all of a sudden, one of them becomes 2. And so I have red 2 plus a blue 0, which will give me 2. So then I'll follow the red line up, and now it's at a height of 2. And then I have 2 plus 0 and 2 plus 0 and 2 plus 0, so I'm okay until I get here. And then all of a sudden, this is where a change happens. The blue becomes 2. Well, 2 plus 2 is 4. So that means that this wave now will be 4 tall. So I was at 0, then I was at 2, now I'm at 4, and then red drops back down to 0. So I have a blue 2 plus a 0 red, which will give me 2. And it stays that way for a little bit. And then both of them become 0. So then I'll drop right back down. So that is the sum of the two waves. If I add the two waves together, I get the green wave. All right, so that's where the green wave is. And then that's what the string will actually look like, or what the spring will actually look like. All right, next we're going to do the 3-second one. Well, the 3-second one is actually easier because you'll have 0, 0, 0, and then all of a sudden the blue becomes 2, and then it drops back down to 0. And the red does exactly the same thing. Then the red's at a height of 2, and then it drops back down to 0. Well, 0 plus 0 is 0, so that's all of this first part. It's going to be 0. And then 2 plus 2 is 4, so that'll jump way up here. This is called constructive interference. Constructive interference is when two waves are going to add up to something bigger. So this is constructive. So the idea being, nothing was really happening here at the beginning, but then both of these are positive 2, which made this 4, which is bigger than the 2 that either one of them had individually. And so I get constructive interference. So that down here, you can just be like, that's constructive. And then the same thing happens here. So now the green kind of follows along the blue because my red was at 0, my blue's at 2, so that's why it ends up here. And then when they're both at 2, 2 plus 2 is 4, so that's why it goes up higher. And then it follows the red line because 0 plus 2 is 0. 0 plus 2 is 2, and then it goes back to 0 again. And then last but not least for this one, this is pretty straightforward. Red is at 0 until it's at 2, and blue does the opposite. It's at 0, and then it goes to 2, and then it goes back to 0. Now this part here, I think of it as one of them is going from 0 up to 2, the other one's going from 2 down to 0. And right at that point, they're kind of crossing paths. So I'm going to just leave it as 2 the whole time. Perfect. So then all we have to do is go back up to the first 2. So this one, same thing. It's just going to stay along that path because it's 0 plus 2 or it's 0 plus 0. And then this one, it's just going to look like this as well because the other one is 0 when the red wave is 2, the blue wave is 0, so it just follows the path of those two separate pulses. All right, so number 2 is very slightly different. I'm going to go ahead and draw the red and blue wave pulses again. Now for this, the only thing that's different is that instead of B being up, B is down. The other thing to make sure you remember is that B is going to go to the left and red is going to go to the right, or A is going to move to the right. And the amplitude or the height of the wave does matter, and the width of the wave does matter. So as you're working through this worksheet, just make sure you're paying attention to those things. Alrighty, so now we're going to go ahead and draw the green line for these. So I went ahead and drew the two different red and blue lines or wave pulses going towards each other. So the red one moved to the right, 1 block per box, and the blue one moved to the left, 1 box per second. And so now we just need to add the green line. And so the green line here is going to stay at 0 because they're both at 0. And then the red one's at 2, so 2 plus 0 is 2. And the tricky thing is that when it goes down, it's negative. So that's a -2. So when I get to here, my green line then is going to go from a +2 down to a -2 because 0 plus -2 is -2. And then 0 plus 0 is 0. So this will go right back. Now that one seems kind of silly and it seems like you're following the line, but just remember that when you get to the next one, we have something a little bit different. So the first part's easy. 0 plus 0 is 0. And so this will just stay here at 0 for this first part. Then it's going to be a red +2 plus 0. So we'll go up to 2 for 2 boxes. And then this is where one of them changes. So the blue becomes a -2 plus the +2. So -2 plus 2 is 0. So that means my green then is going to drop down to 0 in the middle. And then I'm going to have -2 plus 0, which will be -2. So that'll drop down. And then it'll come back to 0 when they're both 0. And there's where it looks like. All right, and last but not least, when you have something like this, you're going to have the red at +2, you're going to have the blue at -2. So when you add these up, you are going to end up with 0. This, instead of it being constructive interference, this is destructive. And so with that destructive interference, it's going to cause it to cancel out. And that's the phenomenon we are going to use for how noise canceling headphones work. If you have any questions, let me know.